Hello class! This is for grade 10 mathematics, quarter 3, module 6, based on the version 5. I titled this video presentation with Introduction to Probability. I am so sorry that the module 6 of version 5 has different title. By the way, I am your teacher, Mr. Anthony G. Arisgado of Bukidnon National High School. This video is for the Icon Live Malaybalay. Are you ready? Let's go! The objectives for today's lesson. At the end of this session, you would be able to define probability, event, sample space, simple and compound events. Differentiate the types of events. Illustrate the different types of events. Differentiate the types of events. Illustrate the different types of events. Illustrate the union and intersection of events and illustrate a probability of an event. Now for the definition of terms. Probability is defined as a ratio of how many times an event may occur as compared to the total possible outcomes. Event is a possible one or more outcomes in an experiment. Experiment is any circumstance whose outcome can't be determined or uncertain. And sample space is the collection of possible outcomes in an experiment. Now for the types of events, we have a number of them. Simple event, an event with single sample point in a sample space. Compound event, an event with two or more sample point in a sample space. The chance of two or more events happening at the same time or two simple events taken together. Independent events. These are events in which the occurrence of the first event doesn't affect the occurrence of the second event. Dependent events. These are events in which the occurrence of the first event affects the occurrence of the second event or when events depend on each other. Certain event. An event that will surely come out in an experiment. Impossible events. An event which has no chance of occurring. Complementary events. A and B are complementary events when A occurs if and only if B doesn't, or B occurs if and only if A doesn't. A and B must be inclusive events. Mutually exclusive events. There are events that cannot happen at the same time. This is called disjoint events also. Now illustrating the types of events. Let us make use of the balls in the billiard game. As you can see on the upper right corner, the balls are numbered from 1 to 15. Examples of simple events using the billiard balls. Simple event number 1, picking a blue colored ball. As you can see there, we have two balls having a blue color, and they are 2 and 10. Now for our sample space, we have the elements 2 and 10 for the set. Simple event number 2, choosing even-numbered balls. As you can see, in the billiard balls, we have also even numbers like 2, 4, 6, 8, 10, 12, 14. So how do we write the sample space? So it is going to be a set of course, 2, 4, 6, 8, 10, 12, 14. I hope you understand a little about simple events. Now let's proceed to the compound events. Let us also make use of the billiard balls. Compound event number 1. Hitting yellow balls and balls with number greater than 10. Take note that for compound events, we are talking about two simple events occurring together. So we have here two yellow balls. We have 1 and 9. And the balls with number greater than 10 are 11 to 15. So the sample space for this is the set containing 1, 9, 11, 12, 13, 14, and 15. Compound event number 2. Choosing balls that are divisible by 4 and balls that are divisible by 3. Again, the compound event is made up of two simple events. So you can see there balls and whose numbers are divisible by 4. Okay, so the sample space for this compound event is given by the set 3, 4, 6, 8, 9, 12, and 15. So I hope you can differentiate a simple event from a compound event. We have here examples of independent and dependent events. Still, we are going to make use of the billiard balls. Situation. Two players hold a contest on who can pick the ball with a greater number with blindfold. So the two players are blindfolded. It is an independent event if, after the first player picked a ball, he or she returned it for the second player to make his or her pick. Take note, the first player returned the ball. Now for the dependent event. If after the first player picked his ball and keep it, then the second player make his pick from the remaining 14 balls. In this case, the first player did not return what he picked. So in other words, for independent event, the two players may have the same ball or the same numbered ball. But for dependent event, the first and the second player will have different numbered ball. Now, example of certain and impossible events. Certain event. Hitting a ball when all the 15 balls are arranged in a line and the cue ball is just less than a meter from the middle of the line. Meaning to say, wherever you strike the cue ball, it will always hit another ball or a numbered ball. Now, another example of certain event in real life is tomorrow is another day. So 24 hours from now, it's another day. So that's very certain. Or every person will die. This is a certain event. Not tomorrow, not now, but of course in the coming days. Impossible event. Hitting a ball whose number is 16. Very impossible, right? Because there is no number 16 in the billiard balls. Okay? So, I hope you can differentiate the two events, the certain and impossible events. Another event to differentiate or to illustrate. Example of mutually exclusive and not mutually exclusive events using the billiard balls. Mutually exclusive events. Hitting an odd numbered ball and hitting an even numbered ball. Yes, these two events are mutually exclusive. There are no common balls in each of the event. The not mutually exclusive event, hitting a ball divisible by 5 and hitting a ball divisible by 10. as you can see, the balls divisible by 5 are 5, 10, 15. And there is only one ball divisible by 10. But there is a common number between the two sets, the number 10. Now, the union and intersection of events. Still using the billiard balls. Say for example, we have a universal set. And it's true, right? Because all the numbers from 1 to 15 are there. And also, let's consider another set, like set A having the elements 2, 4, 6, 8, 10, 12, 14. Okay, so even numbers belong to set A. For set B, we have the balls numbered 1 to 5. Set C, we have the balls numbered 3, 5, 7, 9, and 11. So let us answer following questions. What is the relationship of sets A, B, and C to set U or universal set? What is B union C? What is A intersection B? Number 4, what is A union C? And number 5, what is A intersection C? So we are talking about sets A, B, C and the universal set U here. So let's answer number 1. What is the relationship of sets A, B, and C to U? Okay, A, B, and C, or sets A, B, and C are subsets of U. Now, number 2, what is B union C? When we talk about union, we are going to mix the elements. But if there are elements that are common, then we'll just write them once. Okay, so B union C, I think you can see there common elements such as 3 and 5, but it is just like this. So B union C is equal to the set 1, 2, 3, 4, 5, 7, 9, 11. So as you can see there, 3 and 5 is written only once. Number 3, what is A intersection B? So mean to say, we are going to pick the only common elements for the two sets. So A intersection B has elements 2 and 4. Okay, I hope you understand now what is union of sets or events and what is that intersection of events. Okay, so number 4, what is A union C? So we are going to write all the elements from the sets A and set C. So as you can see, set A, even, set C, odd, but from 3 to 11 only. So we have the elements 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. Now, what is A intersection C? And since there is no common elements between A and C, A intersection C is an empty set or a null set. So no element. Okay, so to make this presentation clearer, let us make use of the Venn diagram. So here you can see our universal set, the rectangle. So we have here the numbered balls from 1 to 15. And of course, our set A has even numbers 2, 4, 6, 8, 10, 12, 14. Then our set B, the balls numbered 1 to 5. Okay, so you can see there, number 2 and number 4 is common between the sets A and B. Meaning to say 2 and 4 is the intersection between sets A and B, or events A and B. Also for events C, we have there the odd numbers from 3 to 11. And between the events B and C, the intersection has the elements 3 and 5. Okay, so this is the Venn diagram presentation or illustration of union and intersection of events. Let's proceed. Now, illustrating the probability of an event. Okay, still using the billiard balls. Okay, so take note that the probability of an event is equal to the number of favorable outcomes for the event divided by the total number of possible outcomes. So for the billiard balls, there are 15 possible outcome. So let's answer the probability of the following events. Using the billiard balls, what is the probability of, number 1, hitting an even-numbered ball? So first event, hitting an even-numbered balls. Number 2, hitting a number less than 9. And number 3, hitting a number that is divisible by 4. So let's answer number 1 first. Even-numbered balls. How many even-numbered balls in the billiard ball set? Okay, so we have 2, 4, 6, 8, 10, 12, 14. So there are 7 balls that are even numbered. The probability of the even numbered balls, it is equal to 7 over 15. Take note that the probability will always be less than 1 except for the certain event. Okay, so you know the certain event, right? Now, hitting a number less than 9 using the billiard balls. So what are the numbers that are less than 9? Of course, it's 1 to 8. How many balls are there? 8. So the probability of this is just like this. Probability of hitting the balls numbered 1 to 8 is equal to 8 over 15. Then number 3, hitting a number that is divisible by 4. Okay, so the probability is equal to 3 over 15 because they are only 4, 8, 12. 3 over 15 is not in the lowest term. So the fraction must be in lowest term. So it's equal to 1/5. So I hope you get this. And if you want to learn more, you can watch again this video in my YouTube channel. And if you have questions, please don't hesitate to type it in the comment section. Okay, let's proceed to the activity of the day. Identify what is described. Number 1, it is a possible one or more outcomes in an experiment. Number 2, it is the collection of possible outcomes in an experiment. Number 3, it is the chance of 2 or more events happening at the same time or 2 simple events taken together. Number 4, it is an event which has no chance of occurring. And number 5, an event that will surely come out in an experiment. Okay, can you guess number 1? Okay, the answer is, it is an event. Number 2, sample space. Number 3, it starts with letter C. Yes, compound events. Number 4, it is impossible. Mission impossible event. Okay, and number 5, an event that will surely come out in an experiment starts with letter C, certain event. Okay, class, for your assignment, how many possible outcomes are there in tossing 2 coins? So you'll do the experiment and write down the results. Number 2, give examples of 1 simple event and 1 compound event in rolling a die. Okay, class, thank you very much for watching. And I hope you learned something. I am your teacher, Mr. Anthony G. Arriesgado of Bukidnon National High School. This is for Icon Live, where math is fun and math is for everyone. Bye-bye!